Hey guys.
All right.
We're back with section 3,
Yep.
chapter 11. Kind of a different section.
Different section.
It's kind of, in a way, comparing or combining similar triangles and polygons and so on that we talked about. What was that, chapter 6?
Yep.
And with our areas that we're talking about now. And so you just need to really work on being able to make these connections, guys. And just seeing that all we're really talking about is proportions.
Yep.
That we did back then, back in chapter 6. And so you can see the title here is Perimeter and Area of Similar Figures. And so we're actually doing both, again, perimeter and area. And really it's all summarized right here in this yellow box. That if the side lengths are in a certain ratio to each other, then the perimeters are in that same ratio because you're just adding them up anyway.
Yep.
And then this makes sense because the areas are measured in square units, so the perimeter the proportion changes to where the proportion is just the squares of each of those sides in ratio to each other. Doesn't matter the shape though.
Nope.
Just because area is measured in square units, and so the ratio is a squared to b squared if the side lengths are a to b. And so they're going to ask you different questions of just making combinations of those things. If the side lengths are in a certain ratio, how do the two areas compare to each other in a similar type of ratio, and they would just be squared. And so let's look at an example here. So we're comparing triangle ABC, the smaller triangle, to triangle DEF, and the white box there tells us that they are similar. So it's given to us that they're similar. The blue one you would kind of have to flip over in order to make the 8 and 12 kind of line up with each other and be the corresponding sides. And so they ask us to find the ratio of the perimeters. Well, from the yellow box again, the perimeters are in the same ratios as the side lengths. And so if we look at those two side lengths that are corresponding, the 8 corresponds to the 12, and so it would be 8 to 12. We reduce that, and so 4 goes into both of those 2 times and 3 times, and so it would be in a ratio of 2 to 3. Okay, so 8 to 12 reduces to 2 to 3, and so since the sides are in that ratio, the perimeters are in that ratio, red to blue. And again, order matters in a ratio, so, okay. Then they're going to ask us the ratio of the areas. Well, if we found that to be the ratio of their perimeters, we're just going to square each one of those. So we square the 2 and get 4, we square the 3 and get 9. Their areas are going to be in a ratio of 2 squared to 3 squared, or 4 to 9. Okay? So really, it's pretty straightforward.
And I think you might have said this, but just remember, guys, always simplify those ratios before you square them if you can.
Just make the numbers easier.
Yeah, it just makes the numbers easier. They're the same if you leave them like that because you could always simplify it at the end, but it just makes it a little bit easier math-wise if you simplify things initially.
Yeah, because if the first one simplifies and you don't simplify and then you square it, it'll simplify again and it'll be even harder to simplify.
Yeah,
so,
exactly.
Yep.
Okay? All right, so now we're going to try it a little bit here. It says the ratio of areas of 2 regular decagons is 20 to 36. What is the ratio of their side lengths? Now look, this one starts off saying area ratios, okay?
So we're going backwards.
So we're going backwards. So you really got to pay attention to what's being said here, because to go from area back to sides, we got to do the opposite of squared, which is square root, and a lot of you guys are going to miss that. So what is the ratio of their side lengths in simple radical form? Well, that means that we got to take the square root of 20 and the square root of 36 to go back to, side ratios or perimeter ratios. Either one, they're the same. Now be careful here. One of these is real easy to square root. The other one, you got to go back in the simplest radical form. So your calculator's not going to help you with the square root of 20. You got to know that becomes 2 root 5, and the square root of 36 is just 6. So we get 2 root 5 to 6. All right. So just remember, to go back from area back to side or perimeter, you got to square root those numbers.
That may look like a weird ratio, but it's okay to have kind of different numbers. It's just a fraction.
Yeah.
It's just comparing 2 numbers. We're just comparing 2 radical 5 to 6. That's okay to leave it in that form.
That's all it is. All right, and then now they want us to find what x, y is here. And so now these are probably the ones that are just a little bit tricky, because you have to look at this and say, what ratio can I actually make here? It's kind of like when we did the geometric mean. You're trying to figure out what ratio, what information can I actually use to make a ratio? Well, the only ratio you really have here is the area of the first triangle is 7 centimeters squared, and the area of the second triangle is 28 centimeters squared, but that's the only ratio you can set up. So you have to go from area ratio back to side ratio here to make this work.
Yep.
And so here's that thing I was talking about earlier where, if you look at 7 and 28 and you look at that and go, wow, how do I square root 7? Remember that there's a rule that says you can square root both of those at once and then, or reduce those first. Sorry, you can reduce that fraction of 7 over 28 to 1/4, okay, to 1 to 4, and then square root that. Now that's the trick here. You got to remember, you've got to square root that, okay? Because it's area, and that gives you that ratio of to go to the side ratio there. They're showing that you got to square root 1 to 4, which changes this ratio to 1 to 2. And now you know your side ratio is 1 to 2, so now you just go back and you plug it in. So 1 represents the small triangle, 2 represents the large triangle. So now I go 1 to 2 equals 4 to x, y, and then I cross multiply, and I get xy equals 8. All right, and so this is the only part that's hard a lot of times when I see kids doing this, is when they look at that ratio, they forget, I got to square root, I got to square root, I got to square root. Another thing that maybe would help you here is if you look at the units of the squares are always squared, and then when you go back to the sides, they're always there in the singular form. And you got to remember to go from square back to, to the first power, you've always got to square root that. I mean, that's kind of how I remember it, I guess. But
Yeah. And how Mr. Bedella figured out the ratio to start with in the first place is that you were given the same measurement on both. It was the area.
Yeah.
If you would have been given two sides, one side on one of them, the corresponding side on the other, then you would start with that ratio. But because you were both given the area of both of them, that's why you started with that.
Yeah.
So,
this one, more than anything else, guys, if you get a little confusing here, when we do it in class, it'll make more sense, because this is one of those ones where by doing it, it gets
practice
easier.
helps.
Yeah.
Yeah.
Okay?
Okay, so we'll practice some in class.
All right.
We'll see you there.
See you there.